All right. So I'm looking at number 5. So number 5 states that in the diagram shown, BC is equal to twice the side length of AB, CD is equal to twice the side length of BC, and AG is equal to 140. And it wants to know what would the length of EF be. So first off, let's just go through and label what we know. So let's say AB is equal to X. All right. Because that appears to be our smallest side. And everything else is written in terms of, 2 times AB, so on and so forth. So BC is equal to twice AB. So if we replace AB with X, what would that be? 2X. It then said CD is twice BC. So what would CD be in terms of X? 4X. Now, they then said that AG is equal to 140. And it wants us to find the length of EF. So let's think about it this way. All right. What would this entire side length be over here if we added those together? 7x. All right. Now, we know that if we set this up in a proportion, it would be 7x is equal to something here, which is equal to 140 over something here. All right. So to solve for x, all we would really have to do is just set 7x equal to 140. Okay? Because if you think about it, let's say you had 3 over 2 is equal to 6 over 4. How do you know what the scale factor is between 3 and 6? You would divide 6 by 2. So in other words, you would multiply 3 by 2. All right? So here, we would take whatever this value is, multiply that to 140. All right? So if we do 7x is equal to 140, divide by 7, x would be equal to 20. So that means that this side length is 20. This side length is right. This side length is 40. This side length is 80. Now, in terms of the proportion, all right, it wants us to find the length of EF. So this length right here. So if we use side splitter, given what we got, all right, it would say that if we added these two together, that would give us 60. And we know 7 times x is 140. So in reality, if we have 140 over 140 is equal to, oh, nope, that's right. 140 over, nope, I'm right, is equal to 60 over, let's say, y. All right. 140 over 140 is 1. So 1 times 60, yes. Sorry, say that one more time. Okay, say that again because I cannot hear y'all. Yep, that'd be true. Yep. All right. So if we want to do that, all right, even if we didn't find out what x was just yet, okay? So I'm second guessing myself. All right, let's say that we wanted to find what EF was. So let's say this is Y. All right. Well, the relationship between AB and AE has to be similar to the relationship between CB and EF. So in reality, this would be 2Y and this would be Y. So 7x is equal to 140, and then we could have x over y. Well, what's x divided by x? So x divided by x is just 7. So this would be 7 over 1. So I would do 7y is equal to 140. So y has to be equal to 20. So this y here has to be equal to 20. Now, if we wanted to do side splitter, or you could just figure out that 20, this would have to be equal to 40. But a way we can check it is that if we use side splitters. So we know that if we want to find between these two triangles, you would have 140 over, let's call that 3y, is equal to 7x over 3x. These x's cancel, so I have 7 over 3. So 3 times 140 is 14 times 3, which is 42. So 4,200 is equal to 3y. Divide by 3. So that would be, oh yeah, it would be, but divide by 21, not 7. Because 7 times, if you cross multiply, I did that wrong. So divide by 21, that goes away. This would be 200. Yeah, 200. No, it wouldn't. It'd be 20. Guys, double check me. You're the one with calculators in front of you. Is it 20? Okay, that's what I thought. So this would be 20. So y has to equal 20 like we just found. So based off of that, EF has to be equal to 40. Because again, let's say we did the side splitter between ABE and ACE. All right, just to double check, you would have x or 2x over x is equal to 20, which we just found as y, not y over 20. So the x's cancel, you would get 40 is equal to a singular y. All right, and that was just if I plugged in a number for y. So you could have said z or whatever. So let's call that z. Okay, that was confusing as all get out, and I'm sorry about that, but Do you guys get kind of the premise of what I did? Okay, so what I essentially did, guys, was I first had to find just what this little piece was. Because if I didn't know what that was, I couldn't find EF. So what I did was I had this entire side. So I knew 7x over something would equal 140 over something. So if I did side splitter, this would have been x, and then this would have been some other variable, we'll call it y, z, whatever. So the x's would cancel because it's side splitter. So I would get 7 over 1 is equal to 140. So 7y would have to equal to 140. So side AE would have to be equal to 20. Then I can do a second side splitter between AC and AF and then AB and AE. So I'm going to call EFC. All right. So I would have to do 2x over x, which is AC over AB, set equal to, let's say, C over, and we know that this is 20. So the x's cancel again. I'm left with 20 times 2, which is 40. And 1 times z, which is c. So EF would have to be equal to 40. So we didn't really need to know what these side lengths were. All right. All I had to do was just use this information because if we put it in side splitter, the x's would have canceled out anyway. Yes. You could. You could. Because they should be proportional. So yeah.
Is there any way you could just take the both side length from what we do and they're all the same?
Yeah, they should be the same. Well, no, because what I started with, I was wrong. Because in reality, we still don't know what x is. All right. So even though I technically solved for x at the beginning, I shouldn't have done that. And that's where I get the confusion line. All right. I meant to set it equal to this value. All right. That was my fault. Yes. Nope. This problem, you didn't need to solve for x. You just had to use it to get to the ratio. So if you knew that you could put these two over each other and that the x is canceled out, that's all you need to know.
So what would the factor you would solve?
You would solve it for EF.
So you like A, B, with EF.
Well, AB would equal AE, and then BC would equal EF. All right, any other questions on that? All right, kind of clear up that confusion from my lovely mistake that I made at the beginning. All right, let's look at number 7. All right, so number 7 is on the coordinate grid shown, AB has endpoints of 0, 8, and 9, 0. Locate 3 points along AB that divide it into 4 congruent segments. So justify how you found the points. So guys, the easiest way to do this is first off, if you want to have 4 congruent segments, well, you can go ahead and get 2 congruent segments by doing what? So think back to when we were doing proofs. What property on a graph created 2 congruent segments? A midpoint. So first things first, to create 2 congruent segments, I can find the midpoint between A and B. All right. So remember, the midpoint formula is this: x1 plus x2 over 2, y1 plus y2 over 2. All right. So if I plug my points in, I have 0 plus 9, which is my x1 and x2, all over 2. And then 8 and 0 over 2. So if I simplify, 0 plus 9 is 9 divided by 2. We're just going to leave that as 9 halves. 8 plus 0 is 8 divided by 2 is 4. So this would be my first point. All right. So that would be about right here. So let's call this point C. Now, that means now that these two segments, AC and AB, are congruent. All right. Now, I can then get 2 more congruent segments. How do you think I would do that? I'll give you a hint. You're still using midpoint formula. Say one more time. Right. Get the midpoint from C to B and then the midpoint from C to A. All right. Because then that would create, that would cut the already cut in half segments, which would give us fourths of AB. All right. So if I find the midpoint from A to C, that would equal 0 plus 9 halves all over 2. And eight plus 4 all over 2. So 9 halves over 2, that's the same thing as 9 halves divided by 2, which is the same thing as just multiplying it by 1 half. All right, so 9 halves times 1 half, that'll be 9 over 4. All right, because remember, you can read this as division. So 9 halves divided by 2. All right, so we have 9 over 4, and then 8 plus 4 is 12, divided by 2 is 6. So that midpoint would be about right, so here's 6, nope, 9/4. So let's see, 9/4, that's 1 past 2. So a little bit past 2, and then all the way up to 6. So about right here. Now, it's not drawn to scale. I just kind of did it my best. But now we know that these two segments are congruent. Do the same thing for CB. So that would be 9 plus 9 halves over 2, and then 4 plus 0, or 0 plus 4 if you want to write it correctly, all over 2. So 9 plus 9 halves, if I rewrite it as fractions, you'd have 18 over 2 plus 9 over 2, so that'd be 27 over 2. And then you got to divide it by 2, or in other words, multiply it by 1 half. So this would be 27 over 4. So this would be 27 over 4. And then 4 divided by 2 is just 2. So 27 over 4, that would be close to almost 9, but not quite as close. No. Yeah, it'd be a little bit past 6, almost to 7. So it'd be about right here and then all the way up at 2. And then these segments are congruent. And since we know that these two segments were originally congruent, that means that all 4 of those little segments have to be congruent. So the 3 points that we can add are all of our midpoints. So it would have been 9 over 2, 4. 9 over 4, 6, and 27 over 4, 2. So guys, that's the way you could have figured it out. If you knew that the mid-segment cut it into two congruent segments, well, remember, if you cut two congruent segments into congruent segments again, those segments have to be congruent. All right, that would have been like saying, let's say this segment was 4, cut it in half right here, that would give us 2. So this segment's 2, this segment's 2. Cut it in half again, this segment's 1, this segment's 1. This segment has to be 1, and this segment has to be 1. All right, does that make sense? So guys, think of a number line. All right, this is 4 units long. Okay, if I cut it in half, how long is each of these? 2. So these segments are now 2. Now, if I cut that in half again, how long is each of these? So if I cut this segment in half, how long is each of these 2 segments? 1. What about these 2? 1. Isn't that exactly what we did over here? All right, we cut it in half using the first midpoint, and then used the midpoint, and then found the midpoint between an endpoint and the midpoint to make 2 more congruent segments. That makes sense now? Yes, no, maybe? And again, that was just a reasoning. So the whole point of that one was you guys knowing that if you took the midpoint between 2 points, that would create 2 congruent segments. You just had to do it 3 times. All right. Any other questions on the homework from yesterday? Yes. All right, number 8. Okay, so Kirk reasons that BC is twice the length of AB. He can conclude that CE is twice the length of BD. All right. And it's saying, why can we say that that's wrong? Well, that's because with side splitter theorem, you would have to use the sides that are not the parallel sides. All right. So you would have to have used these 2 sides. So you'd have to have used AD and DE if you want to use side splitter. So this one would have been one where you just use the similar triangles like we did with the warm up. Because if you added this would have been 12. Well, what's the relationship between 12 and 4? Because we're talking about this small triangle and then the big one, ACE. So what's the connection between 12 and 4? It's a scale factor of 3. All right. So that means that it's actually 3 times the length. And if I check that, well, let's say I wanted to find x. Well, 12 over 4 would have to be equal to 5 over whatever CE is. So if I did 12 over 4 is equal to 5 over CE, this would be 20 is equal mixed it up. This should be CE, this should be 5. See, that's why keeping it corresponding is the way you have to go. Because 12 goes with CE in the triangle, 4 goes with 5 because they're in the same triangle. So 12 times 5 is 60, which is equal to 4 times whatever CE is. If I divide by 4, CE would have to be equal to 15. And does that have the same relationship between 5 as it does 12 and 4? So in other words, if I multiply by 3 to 5, do I get 15? Yes, no, maybe? Yes. So this was one where we could not use side splitter because not enough info. All right. We would have had to know at least what X or what Y was in order to figure out side splitter. But since we didn't have it, we did have enough information to at least use just regular similar triangles. The sides are proportional. Okay, any questions on that one? All right. So let's look at what we're actually going to be talking about today. So turn to page 13. Now, today we're talking about altitudes and how you partition a right triangle with altitudes. All right. So, an altitude is simply just if you drew a line from one of the triangle's vertices to its opposite side, it would form a right angle. That's all an altitude is. So, basically, what it's going to say when if you drew an altitude in a right triangle, it would actually create 3 similar triangles. All right. So once again, when similarity arises, when we draw an altitude from a right angle vertex, so in other words, from the right angle of a right triangle to the right triangle's opposite side, so that would be the hypotenuse. The altitude partitions the hypotenuse in a very specific way due to similarity. So, to kind of put your brain around that with altitude, let's look at this. So I went ahead and I cut this paper into a right triangle. All right, this is definitely a right angle. It's just from a sheet of paper. I just cut it along the diagonal. All right, this is our first triangle. Now, these 2 sheets I made the exact same size as this first triangle. Well, an altitude is just if I cut through the right angle to the opposing side. So let's say I did that. And it's not going to be perfect. All right. Now, let's look at it like this. So here are my 3 triangles that I came up with. There's this one, and this one. All right, and that's just from cutting this triangle down the altitude. So if I put this back on top of the altitude itself, so if I put them back, it would look like this. So my cut that I made right here, that's my altitude. All right. I cut it from the original 90-degree angle all the way to the opposite side. And because of that, it created two new right triangles. Now the question is, are these right triangles similar to each other? And that's what we're about to find out. Okay. So we went from having one right triangle to having three right triangles. And now we're going to find out if they're similar. Okay. So if I'm looking at this first triangle, let's just name the different right triangles. So there's three right triangles. Can someone name me one right triangle? Danny. ABC, that's the original triangle we started with. What's another one? ABD. What's the last one? CBD. So if we label these, ABD's here, CBD is here, and ABC is the entirety of it. All right, so those are our three right triangles that we came up with. Now, we need to find the measures of all of the acute angles in the diagram. All right. So let's look at our big triangle originally. Okay. So if I look at my big triangle originally, my right angle's right here. All right, because that's the corner of the paper. And then also labeled that this angle is 55 degrees. So this angle is 55 degrees. If this is 90 and this is 55 degrees, what does this angle have to be? It should be 35. Right, this triangle's sub here. So what angle did I just find corresponding on that picture? Angle C. All right. So from that picture, this angle would be 35 degrees. Now, that gives us enough information for our yellow triangle, which is our second biggest triangle. So if I had my yellow, all right, so if I had my yellow triangle right here, there it is. Okay, so my yellow triangle is now right here. So again, this is the right angle, and it's marked right there. It's that green triangle, and we know this angle is 35. So what does this itty bitty angle have to be? 55. So this little angle right here has to be 55 degrees. Then our last triangle, so this one, the right angle is right here. We know from side A that this is 55. So what does this angle have to be? 35. So this little angle right here has to be 35 degrees because this one's also 90. So here's my question to you. Are those three triangles similar? Yes, by what postulate? Not angle, side, angle, because we don't know side lengths, but angle, angle. All right. So we can say that all three triangles are similar by angle. So they're similar by angle. So just for reference sake, so we know which triangle is which, because we'll be coming back to it a lot. This is triangle ABC. This is triangle DBC. And this is triangle ABD. All right. So that would be what the triangles look like when I broke them apart. This is our big original triangle, and these are the two smaller ones. All right. So for reference sake, we're going to refer to AB as the small one, DBC as the medium one because it's slightly bigger. We can kind of eyeball that and tell. And then ABC is our large one. All right. So that's just how we're just going to keep referring to them. So I don't want to keep confusing y'all. So we're going to say this is the small, this is the medium, and this is the large. Now, let's say that we draw the two smaller right triangles in the same orientation as the larger one. All right. So the larger one is like this if we drew it separately. So the right angle's here, 55 is here, and 35 is here. So this is A, B, C. That's our large one. Now, if that's our large triangle, let's go to the medium one. So that green triangle that I highlighted or the yellow triangle here. If I oriented it so that the right angle was at the top, all right, so this is our medium. So this would have to be 55 degrees. This would be 35 degrees. What vertice goes with the 55? So look at the yellow triangle because that's what I'm pulling from. Which vertice goes with the 55 on the medium triangle? So where's 55 on this triangle? It's B. All right. You could also look at it from right here. The 55's here, B's here. So this would be B. Which one's connected to the 90-degree angle? D. So this has to be C. Then if we do the smaller triangles, the smallest of the three, still 55, 35. The right angle has to be D because it's in the same spot. What angle is connected to the 55? A. And then B would have to be the 35. So guys, all I did was turn these two triangles to look like this one. But just because we turned them does not mean that the labels are not the same. All right, does everyone understand how I did that? Just the corresponding labels. All right, so that's really the altitude partition. It's basically saying that anytime the altitude is drawn from a right angle vertex to the hypotenuse, three similar right triangles are created. All right, so that right triangle includes the one you started with. So the blue triangle in this case would be our original. And then the two that would form the altitude. So let's say this is new 1 and new 2. All right. And the altitude would be where the 90-degree angles are. So this side would have been the altitude, and this side would have been the altitude. All right, does that make sense? All right. So let's actually do some stuff with this. Now, in the diagram below, triangle EFG is the altitude GH has been drawn to the hypotenuse EF. That EH is equal to 2 and EF is equal to 8. So this right here is our altitude. It was drawn originally from the right angle, so here, to our hypotenuse, which is EF. So this right here is our hypotenuse. Remember, hypotenuse is the longest side of a right triangle. It created that right angle because that's what altitudes do. And they said that EH is 2 and HF is 8. So we're now going to draw the two smaller right triangles below the larger one. So can someone name me one of the right triangles that just got created by the altitude? Eli. FGH. So if I draw a triangle, I'm going to want to orient it the same way as the first. So the first has the right angle here. H is what's connected to this right angle. G is where the altitude is. So it's right across. So G would be here because that's our altitude. And F would be here. All right. Now, what side length do we already know based off of what they originally told us? So they told us two side lengths up here. Which one is contained in this triangle? HF. So HF is 8. All right. Now, one thing that I forgot to say is to mark all the acute angles. Well, let's say that here and here, that's just of the original triangle. So if this was the right triangle, this would be congruent to F. And this side would be congruent to E. So if I mark them over here, F would have 1 tick, G would have 2. Then if I draw the smallest right triangle, the right angle's right here, it should have these tick marks here. We know H is still the right angle, so what letter would have to go with the 2 ticks for the smaller triangle? E. So we just did this triangle, so now we're looking at this triangle. All right. So E goes with the 2 ticks, so that means G is right here. And which side length do we have? EH. So this one would be 2. Now, using what we know about similar triangles, we need to determine the length of GH. So we need to try and determine this length here for both of them. Not GH. Oops. So we're determining the length of GH or the altitude. Now, we know that the green triangle is similar to the purple triangle. So what's kind of a proportion that I can set up? So first off, if we know that GH is the same GH from the purple triangle to the green triangle, that means they're what? So GH for both triangles are what? Because they're the same side. They're congruent. So since they originally came from the same side, they have to be congruent to each other. Because they came from the same side. Why did I just mark that one? Good Lord. So let's call these both x, because since they're congruent, we can name them the same variable. All right. Now, what's true about similar triangles and their side lengths? We went over this morning. They're proportional. So if I start with GH over what's its proportional side, so I'm talking about the GH on the green triangle. So let's call that X. And again, this is from the green, so I'll probably make that green. What's its corresponding side on the purple triangle? So if we look at GH on the green triangle, what's its corresponding side on the purple triangle? 2. All right. So 2 would be its corresponding side from the purple triangle. And it would have to be equal to what's the corresponding side? Let's say this is 8 up here because that's from the same triangle. So that means its corresponding side is X. All right. So all I did was make a proportion, green triangle to its corresponding side from the blue triangle, not the purple, and then green triangle corresponding side from the purple triangle. All right. Is this making sense so far? How I setting this up? Yes, no, maybe? All right. Now, we can then cross multiply. So if I cross multiply, I get x times x, which is what? X squared is equal to 16. What's the only thing I got to do to solve for x? Take the square root. What's the square root of 16? 4. So g of h is equal to 4. So this is 4, and this is 4. And if we marked it here, 4. Now, if we use similarity to find the smaller right triangle from the original to find the length of GE. So remember, this is the medium, this is the small, this is the large. So they want us to use the smaller right triangle, so we're going to use the purple one and the original, so the one that was already drawn for us, to find the length of GE. So we're now finding this length right here, and let's call that Y. All right. So if we look at these two triangles, EG on the smaller one would also be what? It would also be Y. All right. So we're trying to find EG. Let's call that Y. So if I set it up doing from the bigger one to the smaller one, I would have Y over, if I'm going from the larger one to the smallest one, what corresponding side from the large triangle to the small one is Y? So if I start at the Y on the large, so this one right here, what's its corresponding side on this triangle? 2. So this will be Y over 2 is equal to, what is the length of the only other side that I have values for on the large triangle? 10. If I add 2 and 8, that would give me 10. So this hypotenuse is equal to 10. So I would have 10 over what? So what's the corresponding side to the 10 here on the small triangle? It'd be y. So we do the same thing. Cross multiply. This will be y squared is equal to 20. Take the square root. Y is equal to, and we can't simplify that anymore, so we'll just say it's the square root of 20. And we'll leave it at that. Now, if they asked us to actually put that in our calculator and round to something, then do it, okay? Now, it also asks us to simplify the radical. We haven't gotten there yet with simplifying radicals, so we'll put a pin in that. But for right now, we're just going to leave it like that. So guys, these are confusing as all get out because instead of dealing with just 2 triangles, you're dealing with 3. And it's just the orientation gets all messy and everything else. So let's look at exercise 3. So in the diagram, the right triangle RST is drawn with the altitude RU. So here's our altitude. So if I look at all of the triangles as a whole, here's my small one. So this is my small. Here's my medium one. And then the entirety of the original triangle is my large one. So we're going to draw the 2 smaller triangles with the same orientation as the original. So if I draw the smaller ones, let's say I start with the small. All right, so the right angle would have to be up here to look like the original. All right, so this is my yellow triangle. So what letter is the right angle on my yellow triangle? U. So U would have to be here. Now, if we look on my big triangle, let's just mark the other 2 angles as they are. So let's say this is 1 and this is 2 ticks. So if I want it to look like my big one, this would have to be 1 tick, 2 ticks. So what letter goes around the angle with the 1 tick? T. So that means the 2 ticks would have to be what letter? R. So that's my small triangle. Let's look at my medium. So it's slightly bigger. My right angle would have to be up here. I would have a 1 tick angle here, a 2 tick angle here. So this is my green highlighted triangle. So what letter is the right triangle on the green triangle or your medium triangle? Still U. So this would still be U. What about the 1 tick angle? What's the 1 tick angle letter on the green triangle? It would have to be R, because S over here is already the 2 tick. So these would be my 3 triangles if I broke them apart. So if it helps, because there's so much going on in the originally drawn one, let's just draw the biggest one. So the right angle's here, 1 tick, 2 ticks. This would be RTS. So this is the largest triangle. All right. Well, I'm orienting it so it looks like the paper. So we just found the corresponding angles. So the one tick would have to go with the R, because the S has to be. So we're orienting them because it's easier to see the corresponding sides when we orient them. So, for example, when we go to the next problem, RU is 10, TU is 5. So I'm going to label on every triangle that I have where I have RU and TU. So I have a TU on the small one and an RU on the small one. So that would be 5. This would be 10. I only have an RU on the medium one. So that would be 10. And I only have I don't have either on the blue one. All right. So, does that make a little bit more sense why I oriented them? Because now we can clearly see which side is what, or which side is what side. Okay. But sometimes, like, a lot of times you can visualize it, but sometimes, especially when it's like really messy like this, and you have like 3 different triangles in one, it can be kind of hard to see what from what. Okay. So if I want to find the length of SU, so let's call that X. How would I set up a proportion to find it? So let's go with what we have first. So we have which 2 sides already correspond with each other that both have a value already assigned to them? RU and so RU on the green triangle, and which one on the yellow triangle corresponds to that? TU. And that has to be equal to what? So what's the side we're trying to find on the green triangle? SU. And then what's its corresponding side on the yellow? RU. All right. So if I set that up just by plugging in what I have, I would have 10 over 5 is equal to X over 10. Now, I know we can simplify the right side down and everything, but just for solving sakes, I'm not going to do that because it still comes to easy numbers. All right. So I'm going to cross multiply. So 10 times 10 is what? And then 5 times X is just 5X. Divide by 5. X has to equal what? 20. So SU has to be equal to 20. So guys, if the whole concept of eyeballing those 3 triangles to find proportional sides uses you, orient them the same way. So just pick one of the triangles. I suggest the original, so the biggest one. Orient them the same way because it's easier to see the sides. Okay, so like draw them separately so you can see the sides. Okay, any questions on that? All right, one more. All right, so example 4. They didn't give us a diagram, so we have to draw it ourselves. So triangle MNP, where P is the right angle. So I have MNP, where P is the right angle. Now, the altitude is from P to L. So if I drew an altitude from P to L, this would be a right angle. Because remember, it's perpendicular to the opposite side. It then says that ML is 9 and LN is 3. And they want to find the length of PN. So we're going to call that X. Now, a lot of stuff going on here. So we're going to draw the 3 triangles separately. So I have my original, which is MPN. Let's say that M has 1 tick, N has 2 ticks. All right. I then have my triangle, the medium one. So L definitely has to be where the right angle is. If N has the 2 ticks, that means N would have to still be here. And then P would be the 1 tick. And then my last one, so the smallest one, still got the right triangle up here. That's still L. But since M has the 1 tick, it has to go right here. That leaves P having the 2 tick. All right, so here's my small. Here's my medium. And then my large is just the one that's not shaded. So if I label everything with what I got, ML is 9. LN is 3. And they want us to find PN. So X. And then PN's also can be right here. So I just marked it everywhere I had it. All right. Now, we also technically know the length of MN. What would that length be? So look at the very original diagram where all 3 triangles are together. What would that length be? 12. So, which 2 triangles do you think would be the most beneficial to use to find PN or X? So the white, green, or yellow, which 2? The white and the green. Because both of the corresponding sides are marked. So we can set up a nice ratio. All right. This is an example of a problem where they threw an extra piece of information that you didn't necessarily need, except where the 9 came in handy was that it let us figure out this as well. All right. So even though we marked it on the yellow triangle, it's not really relevant. We don't really need the yellow triangle. All right. We just need the white and the green. So everything we're going to do is going to be based around these 2 triangles. All right. So let's set this up. If I start with my 12 on PMN, so the white triangle, what's its corresponding side on the green triangle? X. So its corresponding triangle on the green triangle is X. That'll be equal to X on the white triangle. What's its corresponding side on the green? 3. So if I cross multiply, X squared is equal to 36. What's the square root of 36? So X is equal to 6. So that means PN is equal to 6. All right, any questions on any of this? I know this one was kind of confusing lesson, but it's just because there's a lot of triangles going on there. So again, if having them in one spot confuses you, draw them out. Orient the same, and then label them accordingly. Sometimes seeing it on two separate triangles makes it easier than having it all on one triangle. So there's like a 3 and 1 here, 1 on here. All right, so your homework for tonight will be pages 15 and 16, but I want you guys to skip number 1. So you do not need to do number 1. All right, you guys only got about 5 minutes left. So what I want you guys to do is go ahead and put your calculators away, erase your boards for me, and clean up around your desk. I'm gonna come around and put a name tag on your desk. It's for my second period because they're testing today. That's why it's in rows, by the way. So if you ever see rows, this is typically my testing format. So if you ever see rows and you guys know you don't have a test today, it's probably my other class has a test. Yes, I already posted the key to the homework. Oh, check the homework. I'll check the homework tomorrow because I forgot to do it today. Even though I even made time to do it, it's still, I got busy. So guys, if I put a name tag on your desk, please do not move it for my next class. Also, if you move the desk in any shape or form, straighten them up.
Well, I'm already ready. Sometimes starting on the wrong page, guys. Okay. I should already. That's actually so sweet. What? Can you do that with my math stuff? I was like, yes, also, I looked at her thing, whatever it was. And we got, I heard 3 hours. Wait, 30 hours? When's that? Next Tuesday. I use it. I was told I am going to read it. I was told like, oh yeah, my mom said that basically. Yeah, my mom said actually, she was worried about me last time and stuff, which I'm fine. I hate her for doing it. But she's like, the student emails like all the textbooks.
Bye guys, I'll see you tomorrow.